guy.
The first thing I would like to talk about is the famous rocket equation. All right. So if you're going to study, because rockets are very special, right? And they're very subjective to our human method of propulsion, right? The way we burn gas and we turn that energy into kinetic energy, right, is of course not the only way to gain kinetic energy, but it's, it's relatively easy for us to do. And that's why you see, cars working off of gas, and naturally, planes, and then rockets. And the fact is that gas, or not necessarily gas, but fuel, I guess is the more general term. The fuel has a mass. And the act of burning that actually reduces the mass. And because you're actually carrying that mass with you, it's like the faster you go, the lighter you weigh. And so it's different from just a regular projectile motion equation, but it does hold a lot of similar ideas. For example, actually, not even an example, but
real quick though, it's not really faster you go, the less you weigh. It's just like as you burn more, the less you
not
weigh,
necessarily
which causes
faster.
you to go faster.
Not necessarily faster, because you do have to consider the effects of gravity.
No, of course. I'm just saying by there being less and less weight in the fuel tank, you're just naturally going faster. Also because of gravity and air pressure and all that stuff. But it's kind of like a cause and effect. Anyways, yeah, continue.
Yeah, so I was going to say that projectile motion is, of course, the first thing you would study if you wanted to really understand the motion of rockets, and then, well, not necessarily orbital mechanics, because that's kind of a separate entity.
I mean, orbital mechanics.
From the rocket equation, you don't really need to understand they're related.
Yeah, true.
They're related but separate.
Okay, yeah.
So I was going to say that in projectile motion, obviously, this is a podcast at the end of the day. I'm not going to spell out the equations for you.
Yeah.
But they just deal with, obviously, the velocity of an object along its trajectory, as well as its position, its height in the X, in the Y direction, and all that stuff. But things do change when you have a variable mass. And so the rocket equation does take that into consideration. So imagine your rocket is at m naught. So just the initial mass is just the mass of the rocket, including the mass of all of the fuel. And after a certain amount of time, your rocket has accelerated. So it does have an increase in velocity, but to the expense of a decrease of mass. But as we all know, the thrust, I guess, not the thrust, but the effect of the thrust on the rocket depends on the mass of the rocket of itself. So if we have a constant thrust, but we have a heavier rocket, it's going to take more time to accelerate than a lighter rocket. But since the mass is decreasing with time, then you have to take into consideration how the rocket is not only accelerating, but it's accelerating faster as time goes on. And so that is kind of the essence of the rocket equation. If you want to do your own research, it's called the Tsiolkovski rocket equation. We will link it in the description or whatever.
By the way, I don't know if you heard that quick joke that I made reference to does math even exist or something, when I said it's jerking. When you said the acceleration is increasing, it's jerking if you think about it, right?
That's true.